Spark programming. Spark APIs are based on Scala, Python, Java, and R. API includes functions, subroutines, protocols, and tools to use for building and executing application software programs. A good API will include easy and efficient software programming, versatile functionality, easy management, control, and adaptation, and excellent scaling for easy expansion and fast performance. Looking into these APIs, Java first. This is a general-purpose computer programming language. One of the most popular programming languages used in the client-server web application development platform. It supports object-oriented structures, imperative, generic, reflective, and concurrent multi-paradigm programming. It was first released in 1995 by Sun Microsystems, which was later acquired by Oracle Corporation. On a proprietary license, Sun Microsystems originally had released Java compilers, JVMs, which stands for Java Virtual Machines, and class libraries. Then it was relicensed based on a GNU General Public License in 2007. It is written in C and C++ related syntax, and the file name extensions include .java, .class, and .jar. Scala. And you will see that Scala is a multi-paradigm API that is based on Java, JVM, Java Virtual Machines, and JavaScript programming. It supports functional, object-oriented, imperative, concurrent, multi-paradigm programming. It first appeared in 2004. And the file name extensions include .scala and .sc. Then there's Python, which is a general-purpose high-level programming language. It was released in 1991 for the first time, and it has a design philosophy that is based on code readability. Efficient programming than C or C++ or Java is enabled through Python, which makes it very attractive. It is easier to understand based on its program code, which has a better readability. So both small and large-scale programs can be programmed very efficiently. It includes a dynamic type system and automatic memory management features. It supports object-oriented, imperative, functional, and procedural multi-paradigm programming. It's supported by a large standard library, and it has file extensions .py, .pyc, .pyd, .pyo, .pyw, and .pyz. Looking into R. This is a free programming language for statistical and data mining software development. Automatically, you can see why it is attractive for big data analysis. Primarily written in C, Fortran, and R. It supports arrays, object-oriented, imperative, functional, procedural, reflective, multi-paradigms. It first appeared in August of 1993, and it was developed by the R core team and supported by the R Foundation for Statistical Computing. File name extensions include .r, .rdata, .rds, and .rda. When programming a Spark program, using the APIs discussed, which include Scala, Python, Java, and R, you need to consider the RDD creation methods. You can parallelize a collection of RDD datasets or read data from a data file system, which could include HDFS, the Hadoop Distributed File System, Cassandra, or Amazon Web Services S3. When programming in Spark, the driver program needs to consider the following issues: the number of Spark cores that will be used, and the number of nodes on the cluster that will be used. Number of partitions of the RDD should be proportional to the number of nodes in the cluster to be used. How to take advantage of the cluster's computation capability and achieve higher efficiency and fast processing speeds, where more partitions results in more parallelism. And the number of nodes on the cluster should be proportional to the number of partitions in the RDD. For example, for a 1,000 nodes in a cluster that has 5,000 cores that could be supported, this processing, then 1,000 partitions in the RDD could be considered. The driver program builds a DAG based on sequence of transformations. Executed driver program assigns work to the worker machines. In a worker machine, multiple partitions can be processed by the executor JVM. Actions activate the DAG and the parallel computations, where multiple RDD objects build the operator DAG, where a parent RDD will pass through a transformation or a stage of transformations to result in a child RDD. Persisting operations in the DAG are identified, and the reusable parts are cached in intermediate RDDs. Each RDD partition will have a task executed through a thread of computations, where a job is divided into multiple stages, which is divided each into multiple tasks. The DAG scheduler splits the DAG graph into multiple stages and multiple tasks for execution, and the task schedule executes individual tasks. The JVM executor executes tasks using task threads and the block manager. Then, blocks are served and results are stored on a child RDD. These are the references that I use, and I recommend them to you. Thank you.